Longitudes and latitudes, short notes and formula. It is important that we look at longitudes and latitudes. Why? In our world, they are very instrumental and fundamental in helping us determine our locations and also time. And we begin by saying that they are very important aspects both in geography and mathematics. And for us to venture into it, we begin by a small introduction of great and small circles. If you cut a slice, in quote, through a sphere, its shape is a circle. A slice through the center of a sphere is called a great circle, and its radius is the same as that of the sphere. Any other slice is called a small circle because its radius is smaller than that of a great circle. Hence, great circles divides the sphere into two equal parts, while small circles divide the sphere into two. They do not divide the sphere into two equal parts. Generally, we are talking about great and small circles, even as we advance and go deep into the topic of longitude and latitudes, and we are saying that for the case of great circles, the great circles, they are able to divide equally, to divide the sphere into two equal parts, but small circles do not divide the sphere into two equal parts. And this is a very clear representation of what we are talking about. Great circles and small circles. As you can see, there is this great circle that is cutting the sphere into two equal parts. There is also another circle that is cutting the sphere into two equal parts, and these two, we give them a title, which is a name, which is called a great circle or great circles. And as you can see in the next figure, we have many small circles, but these circles do not divide the sphere into two equal parts. They do not divide the sphere into two equal parts. And therefore, the Earth is spherical, or it is a spherical, a geoid oblate spheroid. It is spherical, it is a sphere. And we are saying there are two imaginary lines that can split or slice the Earth either into two equal parts or two unequal parts. They include latitudes and number two, longitudes or meridian. Two imaginary lines. One of them is a latitude and the next one is a longitude. And we are saying when you look at latitudes, latitudes are generally imaginary lines that run around the Earth, and their planes are perpendicular to the axis. Their planes are perpendicular to the axis. The equator is the latitude that divides the Earth into two equal parts, and therefore it is the only great circle among the latitudes. The equator is 0 degrees, and remember, when we talk of latitudes, for example, in our case, the equator, all latitudes are written in terms of north and south, degrees north and south of the equator. As you can see in this representation, we have our equator at the center, which is able to split the Earth or the sphere into two equal parts. As you can see, it splits the Earth into the northern hemisphere and the southern hemisphere. And as you can see, there are other smaller circles, smaller imaginary lines, 75 degrees, 60 degrees, 40 degrees, 30 degrees. And as you can see, they are not at the center, meaning that these, apart from the equator, all these are small circles. And as you can see, they are written in degrees north or degrees south. The angle of latitude is the angle the latitude makes with the equator at the center O of the Earth. And we are saying the diagram shows the 50 degrees north parallel of latitude. And we say parallels of latitude range from 90 degrees north, that is North Pole, to 90 degrees south, which is the South Pole, as you can see here. We talk about, when we are talking about the angle of latitude, we are talking about this particular angle from the equator to that given latitude. And when it is at 90 degrees north, that is the North Pole, or the North Pole, and 90 degrees south at this particular place, that is the South Pole, and the equator is there. So this is our angle of latitude, And when we come to longitudes or meridians, we're seeing they are imaginary lines passing through the North and South Pole. They can also be said that they are imaginary semicircles that run down the Earth. That is very key. They are half great circles that meet at the North Pole and South Pole. And the main meridian of longitude is the prime meridian, 0 degrees. And they are emphasizing by saying it is also called the Greenwich meridian, since it runs through the Royal Observatory at Greenwich in London, England. That is very key, because remember, when we talk of longitudes, they help us in calculating time. And also, it is important to note this, that other meridians are measured, or other longitudes are measured in degrees east or west of the prime meridian. And last but not least, all longitudes are great circles. This one is very important, especially when it comes to calculation of time, calculation of distance, especially in geography and mathematics. This is a clear representation of the longitudes, the various longitudes, and they run from the North Pole to the South Pole, and the main one is the Greenwich meridian. And remember, the prime meridian, this one here, it is able to split the Earth into the western hemisphere and the eastern hemisphere, and the longitudes are very critical, very important when it comes to calculation of time. The angle of longitude is the angle the meridian makes with the prime meridian at the center of the Earth. The diagram shows 35 degrees east of the longitude. Look at this. This is what we are calling the angle of longitude. This 35 degrees, it is the angle of longitude. As you can see, there is the prime meridian. Then we have 35 degrees east meridian. So the angle, the angular distance that is between the prime meridian and the 35 degrees east meridian, we are calling that angular distance the angle of longitude. Meridians of longitudes range from 180 degrees east to 180 degrees west. Yes, and they are actually the same meridian on the opposite sides of the Earth to the prime meridian. It runs through the Pacific Ocean east of Fiji. And so after saying all that, the longitudes and latitudes in mathematics, they are able to help us calculate distances. They are able to help us calculate distances. And that's why as we come to this other subheading, great circle distances, we are saying, remember the arc length of a circle is where theta, this is theta, is the degrees of the central angle, and the radius of the Earth is 6,370 kilometers approximately. Remember the circle. When we talk of a circle, the circumference, to find the circumference, it is actually pi d, and the area is pi r squared. But if we are talking about an arc length, we shall enter there the specific degrees, which we call theta. On a flat surface, the shortest distance between 2 points is a straight line. And since the Earth's surface is curved, the shortest distance between, say, A and B is the arc length AB of the great circle that passes through A and B. This is called the great circle distance, and the size of the angle AOB, where O is the center of the Earth, is called the angular distance. Note, the length of an arc of a great circle subtending an angle of 1 minute at the center of the Earth is 1 nautical mile. And a nautical mile is the standard international unit from measuring distances traveled by ships and airplanes. 1 nautical mile is equal to 1.853 kilometers. Remember, we have said latitudes and longitudes in mathematics and geography will help us calculate distances between various places using the measurement, using the specific locations, the latitudes and the longitudes. And these are just units of conversion. From nautical miles to kilometers, you multiply by 1.853 kilometers. And therefore, when we come to calculations and formula, one of the formulas that is fundamental is when we are calculating the distance between two particular either locations in terms of latitudes and longitudes, we have to determine the angular distance, which is theta, and therefore the distance or length of that curved part we are saying is equals to theta over 360 times 2 pi r, or theta over 360 degrees times pi d. By this way, you'll be able to get the distance or the length between those curved parts, one curved part to the other. You'll be able to get them in kilometers or nautical miles, depending on the given question. Distances between 2 points along great circles in nautical miles and kilometers. And under this, we say if an arc of a great circle subtends an angle of alpha, this is alpha, at the center of the Earth, the arc's length is given by L is equals to 60 times alpha nautical miles. Or, in other words, what they are saying is the length is equals to alpha over 360 times 2 pi r. And remember, the r that we are dealing with when we talk of great circles is the radius of the Earth. The radius of the Earth. The shortest distance between 2 points on the Earth's surface is the distance along a great circle. Then when we talk of distances along small circle, if the angle at the center is alpha, at the angle at the center is alpha, at the center of a latitude angle theta, then the length of the arc is given by 60 times alpha times cos theta nautical miles, or our distance or the length of that curved part is equals to alpha over 360 times 2 pi r times cos theta, that will be in kilometers. Theta is the latitude angle and alpha is the longitude difference for the 2 points of an arc. These two are very important, very fundamental when it comes to calculating. And of course, the radius of the Earth, or the radius of a great circle, we are saying the radius is approximately 6,370 kilometers. And the radius of all great circles is equals to 6,370 kilometers. Radius of a small circle we talk of r, capital R, the radius of the earth, cos theta, that is the latitude angle. And then from nautical miles to kilometers, you say 1 nautical mile is equals to 1.5853 kilometers. Then speed in knots and kilometers per hour. When we talk of distance, when we talk of speed, the speed of an aeroplane, the speed of a ship, we are able to use the measurement of knots, or you can even use kilometers per hour, and we are saying speed is equals to nautical miles per time in hours, or speed in knots. 1 knot is equals to 1 nautical mile per hour. And from kilometers per hour to knots, you say 1 kilometer per hour is equals to 0.54 knots. Thank you for watching. Ensure you subscribe, like, and share for more content. Thank you so much.